My research interests are with machine learning and natural language processing, and this is exactly what we are having today in this presentation and this research. And what we are going to talk about today. This is about customer support online, so about real people asking things and the real people answering, but we are going to model this and trying to do some things for automatic machines, so for chatbots to mimic this, to simulate this. And so our first focus is customer support online, and then we are going to process textual information. You see to the right one example of dialogue, real dialogue, dialogue by real persons. So, and typical support dialogue is that user asks something and then support personal answers, and then users asks again, and it could continue several times. And yes, and this will be assessed according to emotion intensity. So we want to know how frustrated is user when asking these questions. And yes, we the main idea of our research is to try to model from this text of user how frustrated is this user, and maybe to predict user's frustration in the future in the course of dialogue. And can we somehow influence by answering the right way this frustration level in the next turns of the dialogue? As I said, so our focus is intensity prediction, so emotion intensity prediction, and actually frustration intensity prediction from text. And let's start with the very beginning. So typically, if we talk about emotions everywhere, we typically base on so-called set of Ekman's emotions. So 6 emotions we are going to talk about. If we analyze texts or videos or audio materials, then we try to distinguish these 6 or some variations of this. We are doing differently. So first of all, as I said, this is customer support, conversations between customers and customer support representatives. And we take only one kind of emotions, not these 6, or maybe something around these 6 or some subset of 6, only one, and frustration. So why we concentrate on only on frustration? Just so we have observed that in support dialogues, of course, users have some concern, and the question is how this support is able to solve this problem, and is it possible that when this problem is solved somehow, then this frustration becomes less, so decreases, and can we somehow predict this frustration level? And yes, as I said, this is text, not audio material, but text. And as for grading, it is a very simple scale from 0 to 4. 0 meaning no frustration, 4 meaning high frustration. And so let's go back to the example I presented in the beginning, and this example of dialogue will be shown through over this presentation now. And as you see, we have several turns of this dialog. Starts with user. Of course, user has problem, and then support personal answers, and then user asks again, and then it could continue several times. And so what we have here, this grading of this user's frustration, and also grading of the next user's frustration. And the question is, can we predict this grading from the text you see in this dialog? And yes, our context is that we work together with one natural language processing company in Latvia, and they work with chatbots and with automatic reasoning. The topic of the dialogue, and also very important is this frustration emotional level. And of course, one of the aspects in these chatbot building activities is this emotional part, so emotion detection and emotion intensity detection. And to understand how we can try to model this activity as emotion intensity prediction, we tried to find data, and actually finding data to model this emotion intensity was very hard task, because we wanted two things at a time. So it is support dialogue, so user has problems and support then tries to solve, so goal-oriented dialogues. And if we looked at materials, at sources in the internet, most of dialogues are not goal-oriented. As you see on the screen, this is, yes, this dialogue has emotions, but no goals. No, this is not goal-oriented dialogue. But if we have goal-oriented dialogues, typically they lack emotions. So it's very hard to find data to analyze, to serve as a training data. And finally, we found one source, Kaggle customer support on Twitter dataset. So these are texts on Twitter, so Twitter-based dataset, and we extracted dialogues from this dataset. Yes, in this dataset we can't found directly dialogues. They are Twitter messages with some reference numbers, and we made some effort to make dialogues from this information. So the first activity of us was to assemble dialogues from raw tweet data, because we have no ready-made dialogues on this data. And then what we did, we annotated this data ourselves. We were 3 experts, and we took average, actually median average of it, and so we manually annotated these data, and this is how we created our training set. So to start our modeling of frustration intensity prediction. This is the start of our activity to prepare data, and this was long enough, as I said, to choose from existing sources and to annotate, so to process this data for modeling. And once we got this information, as you saw in the previous slide, we made approximately 400 dialogues. And then we started to do our modeling. Can we predict frustration intensity from the text of the turn of the dialogue? And the second research tasks is, can we predict frustration in the future of this dialogue? So can we somehow from supports party to influence the frustration intensity of user? Of course, we want this frustrated user to calm down, and we want this frustration level to diminish. But is it possible or not? And can we predict it or not? So let's understand once more this task. So what we have text of dialogue. So assuming we already have these dialogues selected and processed, we have text of one turn and user's turn. And the question is, can we predict frustration level of this turn? And the same is about dynamics. Can we predict next level of frustration? So we have the previous turn's text, then we have what support answered, and can we by this predict next intensity of frustration? So these two tasks, current intensity and next intensity, or as you see here, dynamics prediction. So, and this is what we are going to try to do prediction in such two aspects. And let's see how it works. Let's start with actual frustration intensity prediction. So we have turn, and we want to predict the actual intensity. So as a training set, we have 376 dialogues of average length 5.2. So again, let's see at our running example dialogue of 4 turns. This is one of 376 dialogues used in our experiments. And this dialogue is of length 4. So typically, in average, we have longer dialogues. And this is only one example. And the second, if we want to predict current intensities of user turns, so here we have 2 user turns in our dialogue. So these are 2 out of 843 turns used in experiments. This is just for you to judge and to see how big experimental data we have. Yes, experimental data was not big, but just to understand the amount of data associated with our experiments. And so how we did it? We selected words. We used a bag of selected words approach, and we coded these turns as binary vectors. So from these selected words. And what was our proposal and our main idea? Not to use some predefined keywords. So predefined words or tokens, which will be then found in these turns, but we automatically select these good selected words. And our idea is to see from our annotation information which which tokens or which words has a less standard deviation of the ratings according to our annotation by experts. So, for example, if one word is included in several turns, but in one turn this turn is graded as 0, in other turn is graded as 4, so deviation is big. So this word is not good for us as keyword. But if words are included in turns with almost the same rating, so we select them as good. So, and just for example, some best tokens used for encoding. For example, as you see, words unacceptable, lied, terrible. Of course, these are typical words you have big, high frustration. So, but these words were automatically selected from our data set. And yes, how many words, how many best words are enough to represent properly our turn, dialog turn? Also, we tried with several configurations: 50, 100, 30, 300, 500, and we also compared several models to see how many best keywords, how many best tokens are enough to properly represent turns. And yes, for example, if we concretely look at our example dialog, for example, this first turn is represented by 3 words and then encoded into binary coding. The second, the user's turn, is represented that way as bag of selected words. And as I said, these words are automatically selected from the whole data set according to expert annotations. And now we are ready to predict. So we want to having text predict frustration level. And how we are going to do this? So we have these more than 800 turns, and then we have annotations of these, and we want to build model for that, according also using our representation using selected keywords. And we used, actually in that case, nothing very complicated, actually simple enough neural network, multi-layer perceptron with 64 hidden layers. Why? This also was obtained with initial experiments, and input was binary vector representing one user's turn initially, and what is output? Frustration level 0 to 4. This is what we wanted to predict. We want to build such a model. And what are results? So accuracy according to how many keywords were used to encode one turn: 50, 100, 300, 500. So this result accuracy is approximately 40%. And what we can see, 100 keywords is enough to represent one keyword. But the question is, 41%, is it okay or not? Is it good or not? It seems to be not very okay. I would like to have something over 50%, of course. And then how to understand this baseline? We took the average grades from our data set, and we saw that out of 843 turns we had, the most popular answer was 3. So it is almost high frustrated. Of course, but it can be explainable, because if I want support, I'm typically more or less frustrated. So, and if we take this fixed value as baseline, so this is 28%, and this 41% is significantly better. But I don't like, of course, that 41% seems to be not very high accuracy. So what we introduced so-called so-called accuracy with tolerance. So, for example, yes, it was introduced just to say that our results are better than they look like. So, if the right answer, the correct answer is 2, then we simply state that if our program, our model predicts also neighbor values 1 and 3, then it's okay. The same is for 4. If the correct grading is 4, then also answer 3 is accepted. And if we take this approach to assess our models, then of course results are reasonably better, and our accuracy is as much as 80%. So we can very well, we can predict very well, reasonably well, the frustration intensity, and selected keywords. Yes, it's enough 300 keywords in that case. So 100 keywords were enough in this simple accuracy, and more keywords, of course, here. So we could successfully predict current intensity, but now we try to predict dynamics. What does it mean? So we are approaching to the end of the presentation to show you what we mean by intensity dynamics. So if we have current or previous, let's say previous user turn text, and then support with some turn follows, and then can we predict next user's intensity without seeing the current user's text? And yes, and how we compared it, how we chose baseline. Simply, we observed that during the course of dialogue, intensity typically doesn't change a lot, and baseline was simply to take the previous intensity and to automatically put it as a next intensity. This was how we chose this experimental setting, and this is how it looks like in a diagram. And what we got results worse than baseline. So actually, we can predict next intensity, but this intensity can't be predicted better as simply taking the previous intensity for the next turn. So actually, to some extent, we can say we can't successfully predict future frustration, but actually we can, but not better than simply taking the same intensity level from the previous. What does it mean? So it actually means that frustration level, as I said, and as we observed it, doesn't change a lot during the course of the dialogue. And what does it mean? Probably we had not too much data for modeling, and maybe this data wasn't very representative in terms of our problem, because we had no very diverse data in terms of how support answers. Typically, all support personal answers correctly all the time. It's not typically that support answers some other way. Support all the time tries to answer the way frustration level diminishes. And that's why we have objective reasons why in our experimental setting we couldn't get better results for future intensity prediction. But in the end, to conclude that for the current dialogue turn, we can effectively predict intensity from automatically selected keywords. And this is very important, that these keywords were selected automatically. They were not hard-coded and predefined. But if we want to predict next intensity without having this next text, so it is by now not successfully. And as I mentioned, typically during the course of dialogue, intensity doesn't change, objective reason, and support typically support personal acts the same way all the time without different ways how to do this, and try to all the time not to increase or reduce this frustration. So thank you very much. This is about how we tried to predict, and to some extent we succeed to predict frustration intensity from the text in the dialogue.